We're now deep into the territory of anomaly hunting. Hovind's presentation is full of this kind of argument, especially in the area of radiometric dating, where it's easy to find isolated cases where people have applied the techniques incorrectly or to situations where they are known to be unreliable. However, in this case, there really is no problem at all. Hovind mentions several studies, including one in Fairbanks, Alaska and one in Siberia, in which he claims that radiometric dating techniques applied to one mammoth gave wildly different dates. Hovind has got a lot of things very wrong in this report. Most strikingly, if he'd actually read the sources he quotes carefully, or at all, then he would have noticed that in each case the two dates actually came from two totally different specimens of two different ages. So no great surprise that the dates don't match. Hovind incorrectly claims that the samples come from the same animal. This is just shoddy research, misleadingly presented. I'm going to be generous and assume that Hovind didn't know that this was the case, although he certainly does now and doesn't seem to have corrected any of his presentations. The really scary thing is that this particular story from Hovind was actually quoted in an anti-evolution bill that almost got voted into law in the US state of Arkansas in 2001. Yes, that's just 10 years ago, not the Dark Ages, but the 21st century. I find that simultaneously hilarious and also soul-destroyingly tragic. Let's move on. A paper from Baumgartner in 2003 claims that carbon-14 can actually be found in coal deposits that are supposed to be hundreds of millions of years old. Of course, after this time, essentially all carbon-14 should have decayed away, but the levels of carbon-14 measured would otherwise indicate an age of around 40,000 years. Now this is still of course way too old for creationists, but it does appear to throw into doubt the whole concept of carbon-14 dating, or otherwise seems to show that coal deposits might be much younger than the scientifically accepted ages. How can we reconcile this issue? Is it even real? Well, in this case the measurements are actually real. The explanation is not particularly complete yet, but a lot of good work has been done in this area. It should be noted that other methods of radiometric dating do not necessarily suffer from the same weaknesses as carbon-14 when dating coal deposits, and also that this seems only to happen in the case of coal, because of the unique biological origin of this material. Coal is very rarely used as a target for radiometric dating, mainly because it is so notoriously difficult to date accurately and is susceptible to so many potential sources of contamination. The explanation for this phenomenon seems to be related to the decay of the uranium-thorium series of radioactive isotopes in neighbouring rocks, triggering the creation of new carbon-14 from nitrogen-14 in the deposit. Some suggestion has also been made that the cause may have been the presence of organic matter in the coal, such as bacteria, though that seems to be largely unnecessary and unlikely. The uranium-thorium process is definitely the most likely cause, though research is still continuing on this topic. The important message to take away from this case is that we know that radiometric dating techniques aren't perfect. We don't claim that they are perfect, but we do claim that we have done a lot of work investigating the cases where certain combinations of radiometric isotopes can or cannot be used to reliably date certain rock samples. We simply avoid the isotopes that are prone to cause inaccurate dating, and we avoid the rock types that cause problems too. And the fact that we find dating anomalies is fully to be expected. There are 3 papers quoted by Hovind concerning anomalous levels of carbon-14 in various circumstances. In the first example, Hovind mentions a paper by Keith and Anderson from 1963. As you can probably guess by the antiquity of this paper, and in fact all 3 papers on this slide, there really isn't a problem in any of these cases. They're all examples where we know that carbon-14 dating doesn't work very well, and so it isn't generally used there. In this first paper, the authors studied shells of living mollusks and obtained extremely low carbon-14 levels corresponding to dates of 2,300 years old for a creature that's still alive. However, in this case, the snails were living in an extreme environment with poor levels of carbon-14, and also it's well known that carbon-14 doesn't work too well on shells. The main culprit here is the so-called reservoir effect. Environments without a natural source of carbon-14, or aqueous environments where the dissolved carbon dioxide is largely supplied from the source poor in carbon-14, such as limestone, they become deficient in this isotope and hence give unreliable ages from carbon-14 dating. This does not affect most organic materials such as plants and animal flesh. The second example from 1971 covers the case of a recently dead seal that was dated to being 1,300 years old. This is another example of the reservoir effect where certain parts of the ocean, especially the Antarctic where this seal was found, are remarkably deficient in carbon-14 due to upswellings of water from great depth where the carbon-14 has largely decayed. Again, all we're looking at here is a restricted application of carbon-14 to marine creatures from environments with anomalously low carbon-14 concentrations. Finally for this slide, there's another study by Riggs from 1984 showing living snails dated to 27,000 years. Those of you who may be spotting patterns in this slide wouldn't be surprised to know that it's another example of the reservoir effect. In this case, the snails were living near artesian springs where water from deep underground, which was pouring carbon-14, had been bubbling up to the surface. Again, it's easy to test for and disregard. This final slide concerns the method of potassium-argon dating and possible weaknesses with this particular technique. The problems here are partly the result of misleading interpretation of experimental results and partly just a dishonest attempt to discredit a genuine dating technique by focusing on the areas where it works poorly. In the first example, from a paper by Funkhaus and Norton in 1968, yes, over 40 years old, potassium-argon dating was used to date lava samples from recent eruptions and was found to give very old dates. Or at least that's what Hovin says. In reality, the potassium-argon method was used here to date xenoliths within the lava, that is, older rock fragments that become incorporated into the lava flow. In this case, the xenoliths contain anomalously large amounts of argon, and hence the ages were estimated to be old using this technique. Potassium-argon dating applied to the lava itself, however, produced dates consistent with zero age, which is the true and accurate age for these samples. When rocks contain anomalous argon, then the potassium-argon method doesn't work very well. However, the argon-40, argon-39 method can be used instead, as this doesn't suffer the same problems. Mismatches between the ages gained by these two methods can be used to flag up potential issues. Of course, it needs to be stressed that this is only a problem dating extremely young rocks, where the contamination is actually an issue. With older rocks, we don't have this problem at all. The second paper listed is very similar. Dalrymple, the author of this paper, is a mainstream scientist who is absolutely in agreement with the scientific age of the Earth, that is 4.5 billion years or thereabout. In this paper, he measured some anomalously high ages for very young lava samples using the argon-40, argon-36 dating method. If Hovin had bothered to read this paper more accurately, he would have found something interesting. Dalrymple measured 26 samples in his work, only 8 of which had excess argon, and in only one of these was there enough excess argon to cause problems when dating rocks of a few million years old or older. The excess argon causes problems for dating very young rocks, but not for older ones. Actually, in several samples, the problems would have caused an underestimate of the true age. What we've seen in this presentation is the same tactic repeated over and over again. Any creationist trying to pull the wool over the eyes of an audience by claiming that radiometric dating is inaccurate cannot escape a number of extraordinary flaws in their argument that would make any rational scientist discard the objections utterly. The largest that I see are, number 1, the invariability of radiometric decay, both theoretically and experimentally, is so solid as to be beyond question. Number 2, even if decay rates could change, you've got an even bigger problem. Rapid decay would melt the entire Earth, so creationists cannot possibly go with the changing decay rate argument. Which leaves us with contamination. Number 3, the fact that so many methods all agree so well would only happen by chance with coincidences so staggering as to defy explanation. And finally, number 4, we have good methods to test if there is a substantial contaminant and to correct for its effects. There comes a point with a hypothesis where you just have to jump so many insurmountable barriers and throw out such a huge majority of extremely well-established science that the hypothesis stops becoming a possibility and can safely be labelled as absurdist fiction. The young Earth hypothesis, by the evidence of radiometric dating alone, more than meets these criteria. But we've barely even got started so far, and believe me, even without any evidence from radiometric dating at all, there's more than enough to disprove this hypothesis on many times over. Every part of science converges on an old age for the Earth, with remarkable accuracy. As ever, there's loads more information on my website at frame.net, where you can also find a transcript of this talk and all the following ones and all the previous ones, and you can keep up to date with my blog, as well as learning about some of my other work. See you next time when I'll be talking about the beginning of life on Earth, the subject of abiogenesis.